At 1010.
Gone out into the wild, as I say. Over the past 20 to 30 years, we've seen a tremendous proliferation of data that could be used to re-identify individuals in our publicly released data products. These data are collected by the companies we interact with through social media, through data breaches, et cetera. And this growing richness of third-party data about each and every one of us really puts the statistics that we publish at great vulnerability. At the same time, machine learning algorithms and technology have improved such that it's increasingly easy for these algorithms to leverage that wealth of third-party data in an attempt to reconstruct and re-identify the data about us in the official statistics that we publish. And these parallel trends aren't abstract concerns anymore. They represent real concrete threats to protecting privacy and confidentiality for the 2020 census and for other official statistics. So over the past century, the Census Bureau has been a world leader in the design and implementation of the statistical methods that are used to safeguard privacy in public data releases. And as new privacy threats have been identified over the years, the Census Bureau has worked diligently to improve and modify our statistical safeguards in order to mitigate those threats. Our adoption of formal privacy or differential privacy for the 2020 census is merely the latest step in this long history of continuous improvement and innovation to our privacy programs. And it's definitely a necessary one to counter these new 21st century threats that I mentioned before. There's a common misperception, particularly among data producers, that aggregating data is sufficient to protect privacy in data releases. And while that may have once been the case, and it may still hold true for some small or limited data releases, it's increasingly insufficient to protect privacy for large-scale statistical data products. In fact, aggregate tabular data can often be thought of like a giant game of Sudoku, for those of you who might play Sudoku. With Sudoku, if you have enough numbers pre-populated into your grid, then eventually there's one and only one solution to the puzzle. That's the point of the game. Well, the same holds true with aggregate data tables. Once you've published enough data tables, sliced and diced by different characteristics, for example, well, then eventually there's one and only one set of individual level records that could have yielded all of those aggregate tabular releases. And while it might have seemed unthinkable a decade ago for computers to be able to solve for that set of individual level records, computer algorithms can now often perform this quite easily. So database reconstruction poses a tremendous challenge to the producers of official statistics because we can't rely on that aggregation as a step of the protection process anymore. So let's look at a simple example. Imagine that you collected some basic demographics about the 7 people who live on a particular census block. You then publish some aggregate descriptive statistics about those individuals. How many were female, how many were black, what's the median age of the married individuals, and so on. Well, with those basic aggregate statistics, it's a trivial matter to solve for the only set of individual level records that could have yielded those aggregate results. And trivial is really the key word here. It took a 2013 MacBook Pro a grand total of 0.2 seconds to reconstruct those individual level records on the right from those aggregate data on the left. And so now our would-be attacker now has individual level records for everyone living on the block. But the key question is, can she actually re-identify any of them by name? Well, it turns out that this is also a relatively trivial exercise. While the reconstructed individual level records didn't have the individual's names on them, they did have a number of pseudo-identifiers that could be used to link to an outside data source that does have names. In this particular example, you could use age and sex to match the individual level records to third-party data, for example, maybe for registration lists for that block. Now you've got names attached to the records, and you've just learned Jane Doe and John's race and relationship status, 2 variables that the census, for example, includes that often are not included on those third-party external data files. So with these risks, the risks of Reconstruction attacks and re-identification attacks in mind, the Census Bureau wanted to see just how vulnerable our traditional approaches to protecting privacy were in the face of these new types of attacks. So remember earlier I mentioned that the database reconstruction theorem tells us that every time you release any calculation derived from confidential data, you leak a tiny bit of private information in the process. Well, the 2010 census collected a handful of attributes for at the time, approximately 309 million people in the U.S. And that gave us about 1.9 billion confidential data points that we had to protect. But the 2010 census data products that were officially released included over 150 billion aggregate statistics that were derived from those 1.9 billion confidential data points. So our key question here was, were those 150 billion statistics and the private information that they leaked, was that enough to reconstruct individual level records and potentially threaten the privacy of our respondents? So we ran some experiments, and unfortunately the answer to those questions was an emphatic yes. In fact, using only a small portion of the publicly released 2010 data products, Census Bureau researchers were able to accurately reconstruct individual level records for all the individuals in all 6 million inhabited blocks in the U.S. Moreover, we were able to reconstruct detailed individual level information, including sex, age, plus or minus, race, and ethnicity for 71% of the entire U.S. population, again using just a portion of the publicly released data products. Then linking those reconstructed records to commercially available data from the 2010 period, we were able to confirm accurate re-identifications on all of those variables for 52 million people. And so this was a real eye-opener for us. So recognizing these growing threats and the growing insufficiency of our traditional approaches to protecting privacy, the data swapping mechanisms that we've used for the last 3 censuses, the Census Bureau realized that to meet our continuing obligations to safeguard respondent information, we had to modernize our approach to privacy protection for the 2020 census. And that led us to our decision to adopt differential privacy. So what is differential privacy? Also known as formal privacy, differential privacy is a framework for quantifying the precise amount of privacy risk associated with each and every calculation, data table, or data product that you want to publish. And it's independent of whatever third-party data might be available for a re-identification attack now or at any point in the future. Phrased slightly differently, differential privacy as an approach allows you to precisely measure and mitigate the leakage of that private information in your published statistics. And by quantifying that risk, known in the literature as the sensitivity of any calculation or query, differential privacy allows us to mitigate that risk to an acceptable level by injecting precisely calibrated amounts of statistically neutral noise or uncertainty into the calculations. But that begs the question, what constitutes an acceptable level of privacy risk? Well, the only way you can absolutely eliminate all risk of re-identification in data that you want to publish would be to never publish any useful or usable data at all. And clearly, our primary mission being to produce quality statistics about the nation, that isn't a viable option for us. So policymakers at the Census Bureau must find the optimal balance wherein data that are sufficiently accurate for their intended uses, while also being sufficiently noisy to meet our legal and ethical obligations to safeguard the data. And finding this balance between privacy and accuracy is ultimately a policy decision, not a technical one. That said, once you identify that point on the spectrum where the data are both accurate enough and sufficiently protected, that point becomes known as your privacy loss budget. And you'll often see this represented by the Greek letter epsilon. And much like a monetary budget, the lower your privacy loss budget, the less privacy you're willing to give up when you publish your data. An epsilon of 0 would be the world of perfect privacy, but completely useless data. And an epsilon of infinity would be the world of perfect data with no privacy protections at all. So there are a lot of people out there, particularly when we first announced our shift to differential privacy, that said that differential privacy will destroy the usability of data compared to traditional privacy protection techniques. And I want to be very clear that that is just fundamentally untrue. It all depends on how you implement it and the parameters that you set. From the perspective of data accuracy, neither approach is inherently any better than the other. I've seen implementations of differential privacy that have resulted in highly accurate data when they're well designed and when they have a sufficiently high privacy loss budget. And I've seen many implementations over the years of traditional privacy protection techniques that have resulted in terrible data quality and data accuracy when they were poorly designed or when they had particularly high swap rates or cell suppression thresholds. Where differential privacy does fundamentally differ from traditional privacy approaches is on the privacy guarantee front, because formal privacy allows you to quantify the privacy risk, and in doing so, quantify the amount of protection that you're going to apply to the data. With traditional approaches, that was very subjective and ad hoc, and there was no guarantee, regardless of what level you set your privacy protections at. So what does all this mean for the 2020 census? Well, for starters, I want to be clear that our shift to differential privacy does not alter our constitutional mandate to apportion seats for the House of Representatives using the actual enumeration of the state populations. Sorry, there's a bus going by. I apologize. It does not alter our constitutional mandate to apportion seats for the House of Representatives using the actual enumeration of state populations. We will be releasing state population totals as enumerated with no noise added to them. The remaining data products for the 2020 census, however, including the PL 94-171 redistricting data, will have privacy protections applied as they have in prior censuses. Only this time, the noise that we'll be injecting into the data will come from a differential privacy framework rather than from the record swapping mechanisms that we've used in prior censuses. That said, the switch to differential privacy does require us to reevaluate the quantity of the statistics and data products that we will be releasing, as each of those statistics and tables uses up a fraction of the privacy loss budget and impacting accuracy overall. So consequently, the proposed suite of 2020 census data products will be slightly different than it has been in the past. And if you want to learn more about these differences, there'll be a link at the end of my slides, or you can just go to the census.gov website and search 2020 census data products. So as I mentioned before, the selection of the privacy loss budget, that point on that spectrum from perfect accuracy and no privacy to perfect privacy and no accuracy is a policy decision. And the Census Bureau's Data Stewardship Executive Policy Committee, or DSEP, will be making those decisions about the overall privacy loss budget for the 2020 census, as well as the allocation, the divvying up of shares of that privacy loss budget, if you will, to the various data products that we'll be releasing. And you can think of these in kind of three broad categories. What we consider to be the Group 1 data products include the redistricting data and the demographic and housing characteristics files, which are largely the successors to the SF1 from prior censuses. And the Group 2 data products, which include the detailed race tables, detailed ethnicity, and detailed tribal data, as well as more detailed household characteristics. Those would be the Group 2 products. And then there's also a number of ongoing uses of decennial census data later in the cycle, as well as throughout the decade. And so each of those uses will consume a share of that privacy loss budget over time. DSEP is also going to have to decide how to allocate the privacy loss budget even within each of those data products. And that allocation involves giving shares of that privacy loss budget to the different queries and tabulations that are being performed. And those are policy decisions as well, because they will impact the level of accuracy or the relative accuracy of the statistics or tabulations being done at each of those geographic levels for each of those queries. And here's just one example. It's a sample allocation that we used for the May 27th privacy-protected microdata file and detailed summary metrics that we released in the spring. And as you can see in this sample allocation, we were allocating different shares of the privacy loss budget to the different levels of geography and to the different queries at those levels of geography. So, for example, you could say the voting age by Hispanic by Sen race query at the tract level would have had 12% times 29% of the overall privacy loss budget for that product. There have been some impacts of the change of the operational schedule. We are focusing all of our attention currently on identifying the activities and schedules that are needed in order for us to produce accurate and complete redistricting data, the PL94-171 data, by the statutory deadline of March 31st. So as a result, all of our attention is now focused on getting the disclosure avoidance system ready to support of the PL file. Planning and continued development work of the DAS for the production and release of the remaining 2020 census data products, including the DHC files, the Group 2 products that I mentioned before, and others, will restart immediately following the completion of our data planning activities for the apportionment product and the redistricting product. So what have our recent priorities been? So for starters, over the last several development sprints, we've been focusing on hardening the system, both for the integration testing that's necessary to certify that our IT systems are ready for production, and then for production itself. We've also been focusing very closely on efforts to bring data accuracy of the resulting data much more fully under the direct control of the privacy loss budget. For those of you who analyzed some of the earlier demonstration data that we released, you'll know that those earlier versions of the algorithm were introducing some distortions into the data, an upward bias for small geographies and small population groups, and a corresponding downward bias for large geographies and large population groups. Our major attention over the recent development sprints has been minimizing and eliminating those distortions so that the selection and allocation of the privacy loss budget itself determines the resulting level of accuracy. So essentially ensuring that as you increase your privacy loss budget, the accuracy of the data will increase in direct proportion to that increase of epsilon. We've also been focusing very closely on efforts to improve accuracy for legal and political entities, especially for those legal and political geographies that fall off of what we call the geographic spine or geographic hierarchy, and particularly for American Indian, Alaskan Native tribal areas where we saw some notable distortions in those early demonstration data. And lastly, we've been on the kind of IT security side of this, we've been working to ensure the security of our random number generator, which determines the value of noise to be injected into each and every statistic, to ensure that those random numbers can't be essentially reverse engineered, undoing the protections of the disclosure avoidance system. So we did release new demonstration data just a few weeks ago, and corresponding new detailed summary metrics for those data. Consistent with the changes as a result of the operational schedule, those new demonstration data are limited to the tables necessary to support the PL94 redistricting file, which would be tables P1 through P5, table H1. Those demonstration PPMFs have been tabulated for us by the Committee on National Statistics and IPM's National Historical Geographic Information System, NHGIS. So those are available both as a microdata file if you want to analyze them directly, as the detailed summary and metrics which we released, and then also as the tabulations that IPMS has put together for us. Consistent with the prior demonstration data that we've released, we used a privacy loss budget of epsilon equals 4 for the PPMF person file, and an epsilon of 0.5 for the PPMF unit runs, which would be consistent roughly with the share that the H1 tabulations got in the larger PPMF unit runs from prior demonstration products. So some of the major changes that are reflected in the DAS version of the algorithm that was used to produce those new demonstration data, for starters, was bringing American Indian and Alaska Native tribal areas onto the spine. I mentioned that we wanted to show significant improvement in accuracy for the AIN tribal areas, so we modified the geographic hierarchy that the algorithm uses to bring those tribal areas onto the spine. That also included the inclusion of a new state-level AIN tribal area population invariant into the algorithm. So the total population for all AIN tribal areas within each state is now being reported without any noise added, as are the populations for the states themselves. We made significant improvements to the rounding mechanism that's used in the disclosure avoidance system that essentially takes the noisy but inconsistent, internally inconsistent tabulations and converts them back into the internally and hierarchically consistent data that are necessary to support tabulation. We made improvements to that rounder to further decrease the post-processing error and bias that we observed in earlier versions of the algorithm. We switched the noise distribution that we're using for the noise injection from the geometric distribution that we'd used in the past to a discrete Gaussian distribution, which has also improved accuracy. And then we made a number of stability and reliability enhancements to the algorithm. So how did we do? What did the data show us once we ran those? So I mentioned earlier that one of our top priorities had been to improve the accuracy of population counts for legal and political entities. So these graphs show the mean absolute error for counties across the whole nation, broken down by county size. So for comparison here, you can see average error for the October 2019 demonstration data, as well as for the May 27th PPMF release. Dark blue is the October 2019 data, light blue is the May file, and the burgundy is the new September 17th PPMF that we just released. And as you can see, across all counties, the average error was 82 people in the October 2019 data. And hang on one second, bus going back. So across all counties, the average error was 82 people in the data we released last year. By May, improvements to the algorithm, we had reduced that down to an average error of 16 people. With the new PPMF that we just released, we further reduced that average error to just 6.7 people. Altogether, that's a 92% decrease in the average error at the county level from last year's demonstration data products. Also important to note here is the average error across the different size categories. The October 2019 data had large disparities in average error across counties of different sizes. Now the error rates are quite uniform across the different size categories, which helps reflect that we've gotten rid of a lot of those biases that we're seeing based on population size. But it's important to know that counties are counties that are directly on the geographic spine. So how well did we do for improvements to off-spine geographies? So here is the mean absolute error for total population of incorporated places. Again, the dark blue is the October 2019 data, the light blue is the May 2020 data, and the burgundy is the September 2020 PPMF. Across all incorporated places, average error last October was 85 people, which we then improved to about 55 people in May, and then we further reduced that to an average error of 23 people across all incorporated places in the September release this year. Now, given that these are off of the post-processing spine, the geographic hierarchy, you will see a little bit more dispersion in error rates across the size categories. With the smallest error, roughly 17 people in the smallest places, those with a population under 500, and larger error of around 60 people for the largest places, those with a population of over 100,000. But compared to the earlier versions of the algorithm, we substantially addressed the distortion that was noticed in the earlier runs. Lastly, one of our other top priorities, as I mentioned before, was to specifically improve accuracy for American Indian and Alaska Native tribal areas. So here is the mean absolute error for total population of federal American Indian reservations and observation trust lands. Again, the light blue is the May data, and the burgundy is the new September run. There's no comparison from the October demonstration data because those geographies weren't included in the first set of summary metrics that we produced. In the May version, the average error for federal AIRs was 32.5 people. Bringing the AIN tribal areas onto the spine, along with our other algorithmic improvements, we reduced that down to only 6.5 people across AIRs in the new data. And again, average error is pretty consistent across size categories. Sorry, another bus going by. I really apologize for the noise. So as I said, average error here is pretty consistent across the size categories, with even the biggest reservations only rising to about 10.25 people. Now, these are just a few of the metrics of interest. We do strongly encourage you to review the full suite of detailed summary metrics that we published a week and a half ago, and to do your own evaluations of the data, either using the PPMF directly or using the tabulations that IPM's put together for us. Let us know your reactions. Tell us what you think our priorities should be for further improvements. We do greatly value your feedback, and it does directly input into our planning processes, our development sprints, and our priorities for improvements to the system. Here's just a high-level schedule of upcoming deadlines. On October 8th, our Data Stewardship Executive Policy Committee will be having their decision meeting on the final set of invariants to be used for the system, as well as the overall system architecture. In November this year, we will be releasing another set of demonstration data that reflects continued changes to the algorithm and improvements to the algorithm over the current development sprints. In December, DSEP will be having their major decision-making meeting where they set the privacy loss budget and its allocation for the queries, particularly for those supporting the redistricting data products. And then at some point, again, scheduled to be determined based on these operational changes, there will be publication of our schedules and decision points for the remaining 2020 data products. And with that, here are some links for additional information. If you have feedback to provide, I highly suggest sending it in to 2020-@census.gov. We are closely monitoring that account, and we've got a team of data subject matter experts from our population division, geographical experts from our geography division, as well as members of our DAS team, all monitoring that account, and the information that we get from data users like yourselves is relayed to our executives as they are planning and prioritizing for further improvements to the system. So with that, I know we have some time for questions, and I will ask Erica if any have come into the chat window.
Yes. Hey, Michael, it's Heidi. Yes, we did have a few that came in.
Oh, Heidi, I apologize. Sorry.
That's okay. All right. So our first question, has the Census Bureau taken any steps to make using census data and database reconstruction attacks illegal?
So that's an excellent question. And unfortunately, it's not one that the Census Bureau could do ourselves. Right now, the way Title 13 is structured as the law that both authorizes the Census Bureau to operate and that requires us to protect the data, responsibility for protecting the privacy of our respondents and protecting the confidentiality of their data rests on the employees of the Census Bureau. And we would be held criminally liable and face severe fines of up to $250,000 and jail time of up to 5 years were we to release data that could re-identify our respondents. So currently the law is such that it's Census Bureau's obligation to protect the data. There are confidentiality laws out there that do what you're suggesting, where it would prohibit data users from attempting to re-identify individuals. Currently, provisions like that are not included in Title 13.
Okay, thank you. So our next question is a multi-part question, and I think you did touch upon a few of these things in the slides, but we'll go ahead and go through them. So the first one is, how many sprints are planned before the 2020 PL release?
So that is slightly an open question insofar as the operational calendar for getting to the statutory deadline has not been completely finalized. Given that our development sprints typically run about 4 to 5 weeks, it is likely, based on kind of what I would see as the most likely time frame, that there are at least 2 full sprints. The one that just began, at least 1 more before the system would go into production. But again, without having the final operational schedule that reflects the new production deadlines, I can't say for certain that is going to be the case, but likely 2.
Okay. And then the next part of the question is, what issues will these remaining sprints address?
So that is an excellent question. I can tell you that our current sprint is focusing on additional improvements to accuracy for off-spine geographies, as well as more of the hardening of the system that we mentioned before. I can also say we're making additional incremental improvements to address those systemic distortions that we were seeing before. I cannot speak to what would be included in the next, as we're using an agile approach. So the executive priorities for what might be that second sprint before the production run wouldn't be set until the conclusion of the sprint that we're currently in. We've had a chance to look at those data and get feedback from the new set of PPMF demonstration products that we'll be releasing in November.
And that kind of leads into the third question, Michael. What issues will be addressed in the November PPMF release?
So that's an excellent question, and it's all about the work that just began in the current development sprint, which just started last week. I can tell you kind of the way we approach running these is a lot of the DAS development work involves kind of extensive theoretical and kind of scientific research for things that might work. And then we run full-scale national versions of the data with each of those experimental ideas turned on or off in all of the different permutations. And then we evaluate empirically which ones worked best and which combination of those improvements yielded the greatest improvement to accuracy, holding that privacy loss budget constant. And again, all of these demonstration products that we've released have had the same level of epsilon, but that is not going to be or may not be the level of epsilon that's selected for the final production run. We're holding that privacy loss budget constant across these different sets of demonstration data in order to really hone in on accuracy improvements due purely to how the algorithm performs. Then there's going to be the whole evaluation of, okay, what overall level of epsilon is necessary and how should it best be allocated to meet the fitness for use requirements of our data users. But for now, we're focusing on getting the algorithm to behave as efficiently and effectively as it can. And so when we get to the end of this sprint, kind of going back to the initial question, when we get to the end of this sprint, we'll be evaluating empirically all of the different proposed solutions for various aspects in all of their different configurations and looking to see what yielded the best results. And that will be the next PPMF release.
Okay, thank you. And then a few more questions have come in. We understand the decision on invariance will be made this Thursday, October 8th. When will those decisions be shared with the public?
So actually, and I should caveat, there might have been a schedule change since I put these slides together last week. And I think the invariant decision may have been pushed back another week just because of the executive schedule. You can expect, once the decisions are reached, you can expect there to be kind of public dissemination of that information fairly promptly after that. Up to this point, all of the decisions about invariance have been enshrined in decennial census memoranda that have been publicly released. We will likely also release that information via our newsletter. So pretty quickly after those decisions are made, we'll be letting people know. But I would venture a guess that it is likely that new invariance. It is unlikely that new invariance will be considered. It's certainly possible. It is highly likely that the list of invariants will reflect what we've included up to this point.
Okay, thank you. You are bringing AIAN tribal areas onto the spine, and thank you for that. Are other governmental units, for example, cities or school districts, going to be given the same treatment?
So that's one of the things we're looking at in the current. It is unlikely that we would bring other geographic entities onto the spine directly the same way that we did the tribal areas, largely because many of those other legal and political entities are composed of geographic units that are already on the spine. For example, they're composed of counties, or they're composed of tracts, or they're composed of block groups. And so it would be technically difficult to bring them onto the spine because they have to be mutually exclusive geographies in order for the processing to work. And the accuracy gains would not be as high given that they're composed of entities that are already getting those direct geographic measurements. Now, that said, we are evaluating a number of possible solutions to better and more efficiently process the on-spine geographies to improve accuracy for those legal and political entities, and looking at ways to optimize the allocation of privacy loss budget for those entities to improve accuracy for those legal and political geographies. But it's unlikely that we would actually officially bring those other areas onto the spine the same way we did the tribal areas.
Okay, a couple more. Can you elaborate on the impacts of changing from a Laplace distribution to the discrete Gaussian distribution? What did that change do?
So it's a somewhat esoteric discussion, but put simply, the biggest change in switching from the geometric distribution to the discrete Gaussian was to reduce the width of the tails of the noise distribution, which decreases the likelihood that you would just randomly pull a very large amount of error for a statistic. Essentially, it's going to bring the distribution of possible noise values that would be injected much more close to zero, such that it should decrease the variability just due to pulling a bad random seed.
Okay, you mentioned a newsletter. Where would one go to sign up for this newsletter?
Oh, excellent question. So if you go to the first link on the slide here, the Disclosure Avoidance in the 2020 Census website, there will be an opportunity to sign up for the newsletter there. We also have all of our archived newsletters available on the website as well. We don't send out a lot, so we won't be spamming you, but our general time frame is we send out about one newsletter update every roughly 2 weeks or so. And that's kind of the latest news on what we're doing with the DAS, what improvements we've made, what to look for, et cetera.
Okay, great. And then one other one came in. Occupancy rates have improved in the latest PPMF, but still have unacceptable levels of error. What is being done to address this problem?
Sorry, traffic noise again, I apologize. So we are continuing to look at ways of improving accuracy of occupancy rates. That is something that we have recognized through several of the demonstration data runs are concerning for some of our data users. I think, largely speaking, improvements to that would be a function of how much privacy loss budget gets assigned to them. I mentioned that for the recent demonstration data that we released, we used an epsilon of 0.5 for the H1 table. Were DSEP to allocate a larger amount, you would expect to see a proportionate improvement in accuracy.
Okay. Well, thanks, Michael. That has all that has come in the chat, so a few questions, so thank you. And with that, if there's any last questions, please send them in, and I'll turn it over to Erica.
Great, thank you so much.
So this is Erica. Does anyone have any questions? I think my group still has some questions. Does anyone want to unmute and ask? So one of the things, this latest PMF didn't have age. So can you elaborate or talk about how the age tables on the larger table releases beyond the PL data would be impacted?
So that's an excellent point, and that's a function of what I mentioned about the impact of the operational schedule changes. So in order to meet the statutory deadline for the redistricting data, we have focused all of our current DAS development attention on just the specifications for the PL94-171 file, which does not break age down into any finer detail than voting age, non-voting age. As a result, the PMF that we released did not include any further age breakdowns. We will turn our attention back to the broader age breakdowns that are necessary for the DHC files once we can turn our attention back to development and production for those. And you can expect when we release demonstration data for the DHC files to be able to see the corresponding improvements for the set by age tables in particular reflected in those future PPMFs that we do prior to the DHD runs as an as yet undetermined time.
Okay, so I mean, my understanding about how the DAS system works is that if you increase the accuracy in one end, you will have, effects in other areas. And so if you increase the accuracy for the total population, wouldn't you expect that race and age would be affected? I mean, so would we expect that? And that's another thing is the PL data that was just released with the PPMF file did not have, or you haven't presented on the race data. So I'm curious as to what was found there.
Yeah, and I do not, unfortunately, I do not have the race metrics in front of me, though they are reflected in the detailed summary metrics that are available on our website. To your question about if you improve accuracy for one thing, is there going to be a corresponding decrease in accuracy for others? That is the case insofar as you're referring to selection and application of the privacy loss budget. So, for example, in the May release, we had switched around the allocations by query to yield improvements for total population, and that had some corresponding decrease in accuracy for some of the other tabulations. But that's only a portion of what we're seeing in accuracy improvements. A lot of the improvements that we've seen in accuracy, particularly in the September file, were not due to reallocations of epsilon. They were instead due to actually improvements in the algorithm itself. That's why we used the same level of epsilon across the different demonstration data runs. And those are essentially free improvements. If we can get the algorithm to behave better, then you get more accurate data across the board, even for the same level of echelon. So there are improvements that don't come as a zero-sum game. The ones that are due purely to the setting of the privacy loss budget and the allocation of the privacy loss budget by geographic level or by query, those are like a pie, where you increase one query's size of the pie, you're going to decrease the slice available for the others. But a lot of what you'll see in these data are improvements to the algorithm itself that really just work on expanding the pie, so to speak.
Hey, Michael.
Got a new question in chat. Diana is very interested in the results on the accuracy improvement for the race estimates. Can links to the stats be sent with a link to the PowerPoint if you have them?
Sure, I'd be happy to share a link to the details on metrics. They're also available on that website that's linked at the top there.
Mike, did you want to share your G2 questions?
Yeah, I have a question. First, Michael, thank you so much for presenting during your vacation. I sincerely appreciate that. Now the question, will the data tables released after the PL release be constrained to the PL release, or are all the tables going to be consistent?
So that is an excellent question, and I do not have an official answer on that because, again, we're not making any decisions about subsequent data products until we have the schedule for getting done for the PL by the statutory deadline. I can say that it is certainly technically feasible for us to constrain when we run the tabulations necessary to produce the DHC files and subsequent data products. It is technically absolutely possible for us to constrain those to the data in the PL file. But whether that decision will be made to do so, to my knowledge, that decision has not yet been made.
Okay, I would just say that, the prior decennial releases all did that, and that's a lot of our data systems and decision-making processes are kind of based on that assumption. So that would be nice if it did.
Yeah, if I could add onto that, one of the factors that is involved in making that decision is going to be what is the quality of the CEF that is handed over to the DAS team when we go into production for the PL file. Because there is going to be a constrained amount of processing time to turn the cuff into the CEF, it is unclear as of now whether the edits and imputations that would be necessary to produce the CEF for the HC tabulations are going to be done in time for the CEF to be handed off to produce the PL file. And if that's the case, then there may be data quality issues that would inform the decision to make the subsequent data products consistent or not. And again, that's something that we're going to have to see what happens to our operational schedules to get us there. But as I mentioned, it is technically possible and doable for the DAS to constrain the DHC to the PL file if that policy decision is made to do so.
Great, thank you. That I'm sure that's a complicated decision. I do have another question, and it relates to the May PPMF and what I'll just call the female prison issue that was brought up at the recent FSCPE meeting. I'm not sure if it was clear from that meeting, some of the messages or replies in the chat, but, to our knowledge, the group quarter type codes are being set based off the codes in the math. To our knowledge, we don't get to see the full math, but to our knowledge, there are no means to set a prison as male or female, or a fraternity or sorority as all male or all female. And something that wasn't brought up at the meeting in the May PPMF, we also saw some, along with that female prison issue, we also saw some illogical age distributions, senior citizens in college group quarters, adults in juvenile facility GQs, and I was wondering if you or the team has had any chance to start to look at those issues, or if you can elaborate on anything that's being done to address those.
Absolutely, and that's one of the things that is being researched as part of this development sprint. I thank you for mentioning particularly the age and group quarters one, because that's not one that I had heard up to this point. And if you have specifics that you'd like to point out, please send those into the 2020 DAS email box, because we can forward those to the development team that are looking into these. They are looking at ways to decrease the likelihood for those types of occurrences to happen. I know one of the approaches that's under consideration is changing the query structure to actually directly query particularly the sex makeup of group quarters facilities prior to then doing the processing for those as an additional constraint. Whether that will bear fruit, we'll see in the empirical runs, but they are looking into ways to minimize the likelihood that could happen.
Great, that's good to hear. Yeah, I would just add, we can send some examples of that. I think there were some in one of our response letters, but the age distribution issue wasn't as pronounced as that particular female prison issue in our state anyway, but it is, there are values there that are still concerning. So thank you for looking into that.
Although the age distribution would likely not have been reflected in the September PPMF, given that we only had voting age, non-voting age. So it's possible that the algorithm has already improved on that front, but that's certainly something to look at more closely when we do demonstration data runs for the DHC files down the road.
Okay. Will do. Thank you.
This is Erica. Does anyone else have any questions? You can either enter them into the chat or unmute and ask. Last call. Okay, well, I think that wraps this up, and thank you so much for joining us today, Michael, and thanks for your help, Barb and Heidi. And to the STC affiliates, hopefully I'll be setting up a 2020 census wrap-up meeting in the next month or so, as whenever the census actually closes in the field. So when that happens, be on the lookout for an email. And as I've mentioned earlier, I will be posting both the recordings of this training and the slides up on our up on the FCC website within the next week. I'll just open it up to anyone who has an announcement before we sign off. Does anyone have an announcement? Okay, well, thank you so much, Michael, and we'll be looking forward to the information and additional work you're coming out of your unit. you.